Hello, class. It's nice to meet you once again. So today we'll be looking at atom economy. By the end of the class today, you should be able to state the formula for finding atom economy and also find the atom economy of a reaction. Why are we concerned about atom economy? It is important to be able to determine the atom economy of a chemical reaction or process. This way, engineers or production chemists would be able to determine the best method or best process for the production of certain chemical products. Let's begin with what chemical reactions does. Chemical reaction is geared towards producing specific product. So in some reactions, there is only one product, which means all the reactants end up to form a single product. A good example of such reaction is when you react steam with ethene, you get ethanol. That is the only product you get from that reaction. So what this implies is all the reactant ends up in the desired product. However, there are some reactions that comes with byproducts. So you have the desired product, and then you also have the byproducts that are formed. A good example of such reaction is the fermentation of glucose, for example, will generate ethanol, which is the desired product, and carbon dioxide, which we don't want. So how do we determine the atom economy of a reaction? The formula is simple. It's actually 100 times 100 times the relative masses of all the reactants. So the masses of all the reactants and divided by those of the products. Okay, so and the product we will focus on will be the desired product. Formula is that simple. Now let's put this formula to use by looking at the first example here. Here we are told to calculate the atom economy when ethanol is made from glucose. This process is known as fermentation. We are demanded to leave our answers in three significant figure. Now, like I said earlier, when we ferment glucose, the essence of doing this is to obtain ethanol, which is a desired product. But alongside this product, carbon dioxide is also produced. Now let's calculate the atom economy of this entire process. Remember, this is not the only reaction that produces ethanol. Earlier in the class, we said that when you react steam with ethene, you also get ethanol. But this one, you only get the desired product. But with fermentation, you have a byproduct formed. So now let's look at the fermentation process where a byproduct is formed to see how the atom economy will look like. So let's start with the relative masses of all the reactants in this equation. You know, we have glucose, which is C6H12 O6. There's a formula for the glucose that is then fermented to give us 2 moles of ethanol and 2 molecules of carbon dioxide. Okay, so we go with that now. Let's start with the glucose. For glucose, we have 6 carbon. We have 6 carbon as suggested in the table here. So I will just give us glucose as 180 to save our time. If you're surprised, I will go 180. From a periodic table, the mass of carbon is 12. So 12 times 6, that's 72 plus 1 times 12. And then plus the mass of oxygen is 16. So that's 16 times 6. All this amounts to 180 as our reactant. So let's move on to getting the desired product. For the desired product, we have 2 times for carbon, we have 12. So that's 12 times 2. The reason why I place this 2 times here is because we have 2 moles of ethanol. So 12 times 2 plus 5 times 1 times 5, because hydrogen is 1, plus 16, and then plus 1. Remember, we have no business with the carbon dioxide. We only have business with our desired product. So this gives us 46, and then 2 times 46 gives us 92. So now we have our product, and we have our reactants in the equation. So the next thing for us to do is to go ahead to get our atom economy, which is 100 times the product, which is 92, divided by the reactant, which is 180. And this gives us 51.1%. 51.1%. So this product, what this simply means is the atom economy for this reaction is a bit low. It's around 51.1%. So I would encourage you to try out the next question, which says calculate the atom economy when titanium is made from titanium chloride. Thank you for watching this video. I'll be looking forward to seeing you in the next video. You can make this possible by subscribing to our Direct Start channel. Make sure you click the subscribe button and like this video.